As I stated at the beginning of the video, that at grade 9 we will discuss three types of factorization. The first type that we already discussed was factoring by HCF. The second type that we will talk about is the difference of two squares. Now, I'm not going to discuss this idea too formally, right? Because it's a very basic idea, but I'll give you a more complete outlook at grade 10. As I said, that at grade 9, because we are discussing three different ideas, I can't really give you a good overview on the entire topic until we get to grade 10 when we discuss the remaining parts of factorization or the remaining techniques of factorization. Then I can only give you a good overview of the topic, right? But for now, for the difference of two squares, right, this is how it goes. Remember when we had under the products of binomials, we said a plus b, the sum and difference of two terms, will result in what? The difference of two squares. Remember, we employed the SMS rule. We said square the first term, a squared, square the second term, b squared, and write the minus sign, SMS. Now, if we're saying that products and factorization are direct opposites of each other, if this is going in the forward direction, then the factorized form must be in the reverse direction. So how would you get the factorized form? The factorized form is found by square rooting the first term, right? That will be square root of a squared is what? A. Square root the second term, the square root of b squared is what? B. And it'll be a plus b, a minus b. Very simple. So if you're given, watch here, if you are given two perfect squares separated by a minus sign, the result of that will be the square root of the first term plus the square root of the second term, and it'll be the square root of the first term minus the square root of the second term. That basic, very simple. So in order for you to utilize this rule, and I want you to write this down, you must have two terms, right? It's only applicable for a binomial, two terms. Those two terms must be perfect squares. Perfect squares. And the last condition, separated by a minus sign. So you must have two terms. Those two terms must be perfect squares. So this term must be a perfect square, that term must be a perfect square, and it must be separated by a minus sign. Given any other question, if you had two terms and they were perfect squares and they were separated by a plus sign, you cannot solve that question. If you were given three terms and those three terms were a perfect square and they were separated by a minus sign, you cannot solve that question. In order for you to utilize this rule, you must satisfy these three conditions. This is why factorization, this is why so many students find factorization so difficult, because they don't understand the conditions under which any technique applies. So they don't understand the conditions under which this technique applies. It applies under the condition that, or on condition that, you have two terms, they are perfect squares, and they are separated by a minus sign. As soon as you see that, this needs to come to your mind. So let's do an example. Let's say that we're given x squared minus 16. X squared minus 16. In order to get the factorized form, we'll square root the first term plus the square root of the second term, 4, and the square root of the first term minus the square root of the second term. Done. Very simple. Now, there's one complicated example that you could get here, right? Let's say that you have x to the power 4 minus 16. To factorize this, it'll be the square root of the first term will be x squared plus the square root of the second term, which will be 4, and the next bracket will be the square root of the first term minus the square root of the second term. Now, in this case, you see this bracket here. This bracket can further be simplified into a difference of two squares as well. So therefore, it will be x squared plus 4 into x, the square root of the first term plus the square root of the second term, the square root of the first term minus the square root of the second term. And that's how you simplify the question. So this is the product's outlook, but we go in the reverse direction to get the factorized form. Right. So yeah, they are wrote it here formally. If the exponent is a multiple of 2, so see this exponent here? It's a perfect square, but it's a multiple of 2. We must employ the rule more than once. So don't worry about the word that I wrote here, just write the word rule more than once. That is, we must ensure that every factor is factorized into its simplest form. This is what is meant by factorize fully. Now, you will notice that in a lot of the questions, they'll tell you factorize fully. Full stop. What that basically means is after, see for example this here, I did the first level of factorization. There's it here. This is the first level. Then I need to look at each factor and check, can I factorize those factors further? And if you can, then you have to factorize it. And that is what is meant by factorize fully. So you ensure that every factor, this factor and this factor, is in its simplest form, right? See here again, can you employ the dots rule? Okay, let's do the check. Do you have two terms? Yes, you do. Do you have, are both these terms perfect squares? Yes, they are. But are they separated by a minus sign? No, they are not. So therefore, you cannot employ this rule, right? And the dots rule is this simple. So there's nothing difficult about the difference of two squares rule. In the next part, we will discuss factoring of trinomials. Okay, that's about it.